Hello friends, today in the sixth lecture of the Laplace Transform, we shall now study some specific types of functions, and thereafter we would be determining the Laplace transform and their effect on f of t, and their applications. So, let us start with the unit step functions. U of t say or h of t. It is also referred to as the Heaviside's unit step function. It was first introduced by the British physicist Oliver Heaviside. That is why the name is given after him. H of t, many authors denote them as u of t. How we define this? How he has defined this function? Unit step function. H of t is equal to 0 when t is negative and is equal to 1 when t is non-negative, greater than or equal to 0. That is how we define this unit step function. It can be better understood by its plot or its graph. If this is t-axis and this is say u of t or h of t axis. For negative t, on the left of this u of t axis, for all those values it is 0. So for all those t's it is 0 up to 0. And for negative t it is 0, and for t greater than from 0 and onwards it takes value 1. Value is 1 from 0 and onwards up to infinity. So that is how we plot this unit step function. It is as good as the function denoted by say f of t or u of t. If f of t is denoted by u of t, it is equal to 1 for t greater than or equal to 0. And the Laplace transform of 1 that we have already seen in the very first lecture is 1 by s. Therefore, Laplace transform of u of t is equal to 1 by s. So Laplace transform of this unit step function is 1 over s. Now, we would be discuss the effect of multiplication of this u of t to any arbitrary function f of t. Effect of multiplication of u of t or say h of t. So consider any f of t arbitrary function. Now, f of t, if it is multiplied by u of t or h of t, what would be its effect? That we shall see. Now, when t is negative, u of t is 0. So 0 into f of t would obviously equal to 0. Now t is when non-negative, u of t takes the value 1 throughout. So f of t into 1 is equal to f of t. So that is the very wonderful feature of the effect of multiplication of u of t to any arbitrary function. What does it mean? If f of t is any arbitrary graph, consider this f of t as parabola, y equal to x square or f of t equal to t square. This is f of t. This is t axis. This is f of t axis. Now, what would be plot of f of t into u of t? Plot of f of t into u of t would be equal to this portion only. This is plot of f of t into u of t. Because when t is negative, f of t into u of t becomes 0. It is 0. This is t axis. This is f of t, u of t axis. So what does it mean? If we multiply any arbitrary function by u of t, then its effect is the filtering. It filters the portion of graph towards the negative axis. It curtails the graph of this parabola towards the, ये इतना ग्राफ पूरा कट हो जाता है, फिल्टर हो जाता है. It would allow the signal for t greater than or t greater than or equal to 0. ये इतना ही पोर्शन, इतना ही सिग्नल देगा वो. That is the effect of multiplication of u of t to any arbitrary graph f of t. Now, let us consider the second specialized function. Displaced unit step function. It is also called as delayed unit step function or delayed unit step function. It is denoted by u of t minus a, or it is also denoted by h of t minus a. So how it is defined? It is defined like this: u of t minus a, it is equal to 0 when t is less than a, and it is equal to 1 when t is greater than or equal to a. It can be better understood by its plot. If this is t axis, this point is a, suppose this is u of t minus a axis, the function is denoted by u of t minus a. Now when t is less than a, u of t minus a takes the value 0. So towards the left of this point a, t equal to a, the value is 0, and t axis equal u of t minus a is 0. Whereas when t is equal to and greater than a, it takes the value 1. Up to infinity. It is giving the unit signal from t equal to a and onwards after that. That is the meaning. That is why it is also called as the displaced or delayed. At time t equal to e is providing the signal of unity. So that is how. From the plot itself, it can be better understood. Now, effect of multiplication of any arbitrary function f of t of this function u of t minus t. Now, f of t u of t minus a. Consider f of t is any arbitrary function. We have taken parabola and this u of t minus t. Now, when t is less than a, this u of t minus a is 0. So, 0 into anything is 0. Now, when t is greater than or equal to a, its value is 1. 1 into f of t is f of t. So, what does it mean? Effect of multiplication of u of t minus a to any arbitrary function f of t, that does mean that the portion of f of t is filtered or curtailed towards the left of point A. Earlier it was towards the 0. Now towards the, let me plot this function. If f of t is parabola, this is parabolic plot, this is t axis, this is f of t axis, f of t is equal to t square graph. Now what is the plot of f of t into u of t minus a? It would be, this point is a, so it gives us the parabola. This much. If this point is a, it allows only this much up to infinity, this portion of parabola. This is denoted by up to this port. This, the portion of parabola towards the left of a has been curtailed, has been filtered, has been omitted. So, it allows the signal or f of t towards the right of t equal to a. So, that is how we define the effect of multiplication of this delayed or displaced unit step function to any arbitrary function. Now, third, rectangular wave function. Rectangular wave function. It is denoted by u of t minus a minus u of t minus b, where a is strictly less than b. It is also called as pulse function. Why it is called as a rectangular wave function? Name given after this that we have seen now. Now, how this rectangular wave function is defined? Let us define this. It is defined in its standard format as u of t minus a minus u of t minus b is equal to, it is equal to 0 when t is less than a. And is equal to 1 when t lies between a to b. T lies between a to b. And it is again 0 if t exceeds or greater than b. That is how basically we define the rectangular wave function, or what we say as the pulse function. It can be better understood once again by its plot. This is the u of t minus a minus u of t minus b axis. This is t axis. This is, say, suppose t equal to a, and this is equal to t equal to. Now let me define the plot this function. Now this is defined. It is 0 when t is less than a, strictly less than a. So it is 0. For all these values, it is 0. Now when t is equal to a and it lies between a to b, t is equal to a and t is equal to b, its value is 1. So this is 1. So from this point a to this point to b, the function takes value. If this point is suppose 1, on this u of t minus a minus u of t minus b axis. So when t is less than a, it takes the value 1. Sorry, when t is less than, value is 0. When t is from a to b, its value is 1. Again, when t exceeds or greater than b, after this it is 0. So, from a to b, it is 0, then it is taking value 1 up to b, and again it is 0. Its shape is somewhat rectangular type. That is why it is called as the rectangular wave function. Now, effect of multiplication of this rectangular wave function to any arbitrary function f of t. F of t into u of t minus a minus u of t minus b. Now when t is less than a, value is 0, 0 into anything is 0. When t lies between a to b, when t is less than a, when t lies in this closed interval a to b, then its value is 1. This bracket's value is 1 into f of t is f of t. And when t is greater than b, its value is 0 into anything is again 0. So what does it mean? The effect of multiplication of f of t, that does mean it allows the portion of f of t in its interval a to b. Outside this interval, it filters the plot of that graph, signal of that graph, the portion of that graph. It cancels out, it curtails, or it omits, or it rejects. For example, if this is t-axis and this is, say, suppose any plot of f of t. Okay, and then what would be plot of f of t into u of t minus a minus u of t minus b? If this point is a, suppose this point is b, so it allows this portion of graph, this portion. It rejects this much portion and this much portion. It allows only this much portion of this graph of this f of t. Which portion? Portion from a to b only. It allows only this signal from 4 a.m. to 5 a.m. It will siren like that. So these functions, they are as good as the filtering functions, filtering noises and all that. It has wide number of applications in communication engineering also, Laplace transform, specialized, a special class, specific class of functions. So that was, it is also called as pulse function. It gives us pulse from time A equal to time B. Now, we have seen the Laplace transform of u of t is 1 by s. Now what is Laplace transform of u of t minus a? It is perhaps equal to e raised to power minus as upon a. How? Let us find out it. From definition, it is equal to integral 0 to infinity e raised to power minus st into u of t minus a dt. It is further equal to integral 0 to a e raised to power minus st into u of t minus a plus integral a to infinity e raised to power minus st into u of t minus a. Now from 0 to a, we have seen in the graph, this function takes value 0. So first integral is 0. Whereas from a to infinity, from a and onwards up to infinity, this u of t minus a, that takes the value 1. So this reduces to evaluate a to infinity e raised to power minus st dt. Only that will be your required Laplace transform. Integral of e raised to power minus st is e raised to power minus st upon minus s, a to infinity. E raised to power minus infinity is 0. 0 upon minus s is 0. Minus. Now lower limit. E raised to power t equal to a minus as upon minus s. So in particular, it is equal to e raised to power minus as upon s. The Laplace transform of u of t minus a. Note this. Laplace transform of u of t is 1 by s and that of u of t minus a is e raised to power minus as upon s. Just we have seen now. Most important result. Laplace transform of f of t into u of t minus e. Let us find it out. It is equal to perhaps e raised to power minus as into Laplace transform of f of t plus a. How it comes, we shall see this now. So, from definition again, integral 0 to infinity e raised to power minus st into this function f of t into u of t minus a. This is further equal to integral 0 to a e raised to power minus st into f of t into u of t minus a dt plus integral a to infinity e raised to power minus st into f of t into u of t minus a dt. Again, from 0 to a, u of t minus a is 0. So value of first integral is 0. Whereas from a to infinity, u of t minus a is equal to 1. So 1 into this function is 1. So it is equal to, first integral vanishes. Integral a to infinity e raised to power minus st into f of t into 1 into dt. So limits are from a to infinity. They are not from 0 to infinity. Otherwise it would have been the Laplace transform of f of t. So how to transform these limits into from a to infinity to 0 to infinity? By simple substitution. We put this t minus a is equal to say x. I am transforming, changing from t to x. So when t is equal to a, x is equal to, it becomes 0 now. Now when t is infinity, x is also infinity. dt is equal to dx. So let me substitute all these changes. A to infinity that goes from 0 to infinity. E raised to power minus s into, what is t? T is equal to a plus x. Into f of a plus x. dt and dx they are set. So that is further equal. The t has now been changed to x. So s is treated as independent of x constant. So e raised to power minus a is, I am taking out 0 to infinity, e raised to power minus sx into f of x plus a dx, or in other language it is equal to e raised to power minus as into integral 0 to infinity e raised to power minus st into f of t plus a. As the integral is definite integral, the dummy variable x can be replaced by t. It does not change the value of the definite integral. That is the property of definite integral. So, this is the deduced result of the Laplace transform of f of t into u of t minus a. That comes out as e raised to power minus as into this. And what is the meaning of this? Integral 0 to infinity e raised to power minus st into f of t is the Laplace transform of f of t. But here in this integral it is integral 0 to infinity e raised to power minus st, but instead of f of t it is f of t plus a. So this is nothing but the Laplace transform of f of t plus a. That is equal to e raised to power minus as into Laplace transform of f of t plus a. Most important result. This we would be using in solving various problems. Laplace transform of f of t into u of t minus a, once again I am repeating, is equal to e raised to power minus as times the Laplace transform of f of t plus a. Thank you very, very much.